Hi everyone, welcome to the day 4 of our algebra review camp. So today we'll be going over an algebra 1 topic, and that is the domain and the range of a function. Okay, so maybe you don't know what is a function, that's fine. So let me just briefly introduce that to you. So a function is basically a thing that taking some independent variables and we call them the x. And then after we give the function some variables, they will return us some variables, and we call this the return variables as the dependent variable. Okay, and you can think of the function as like a food blender. Okay, so imagine if you put in some strawberries into your blender, you may have a strawberry smoothie. And if you put in a watermelon, you can get a watermelon smoothie, right? But what does the domain and the range of a function? So the domain is basically just all the possible values of the independent variable. Okay, so we have the domain here is just all the possible values of the independent variables. Okay, so for the blender, it could just be all the food, right? It could be some fruits, strawberry and watermelon, or it could be some vegetables like I don't know, maybe spinach, right? So it could be all the other food, but you cannot put say rock into a blender, right? Otherwise, your mom will be super mad about you. Okay, so the rock here cannot be putting into a blender. Okay, so we need to have some domain for this function because we know certain values cannot be inserted into this function. Okay, and similarly for the range, it's just all the possible values of the dependent variable. Okay, so the range here will be for the dependent variable. So again, since you cannot put in a rock into your blender, then of course you cannot have a rock smoothie in return. Okay, so that's why we also have the range. Okay, so if we understand what is a domain and what is a range, let's see if we can determine the domain and also the range in the following functions here. Okay, so the first one, we see that the y here, which is our dependent variable, is equal to an expression. Okay, so in this expression, we have the x. So basically, if you plug in the x equals to 1, x equals to 0 into this function, you can always get a y in return. Okay, so that's how the function works. And now we see that, do we have any restrictions on the independent variable for the x? We see that we do have a fraction here for this expression. And remember that for a fraction, we know the denominator cannot be equal to 0. Okay, otherwise the fraction will not be defined. Okay, so we know the denominator cannot be equal to 0. In this case, we know the denominator is x squared minus 4. Okay, so this is the denominator of the fraction. And we do know that we have a restriction on the denominator, and that is the denominator cannot be equal to 0. Okay, so here we have our inequality, and we see that in this inequality, we do have our independent variable. So solve that, we have x squared doesn't equal to 4. So solving an inequality is just similar to solving an equation. Okay, and then we have x is not equal to 2, or x cannot be equal to -2. Okay, so be careful here, since we know that 2 to the power of 2 is equal to 4, as well as -2 squared is also equal to 4. Okay, so we have these two inequalities for the x, and this actually specifies a range for the x, for the domain, right? Because we know x cannot be equal to 2, or x cannot be equal to -2. So this one here will just be the domain of this function. Okay, so this is one case of finding the domain, because we do know that we have some restrictions on the denominator. And now if you look at the second function here, we have a radical expression. Okay, so for a radical expression, we know this one here is just a square root, right? And for the square root, we do have some restrictions for the number under the square root. Okay, and that is this number has to be greater than or equal to 0. Okay, because we cannot have a, say, square root of -4, right? Because we know everything take to a square root must be positive or 0. So we know that this number here has to be greater than or equal to 0. Also simplify this inequality, we have 2x is greater than or equal to -5. So x should be greater than or equal to -5 over 2. Okay, so this is how we can get the domain of this function. And by the way, do you know how to find the range of this function? So here we see that the y is actually equal to a radical expression. And by definition, the radical expression can only be greater than or equal to 0. Okay, so if you want, you can also find the range of this function which is y is greater than or equal to 0. Okay. So we see that we can find both the domain and the range of the function based on this expression. Okay. So this is how we can find the domain and the range. And just to sum up, if you see an expression with the x in the denominator, make sure that denominator cannot be equal to 0. And if you also see a radical expression, then make sure that the expression inside this radical expression should also be greater than or equal to 0. Okay, so these are the two most common cases we can see if you try to determine the domain and the range. Okay, so that's it for today's topic, and I will see you guys tomorrow. Okay.